Good morning. Welcome back. I'll give you a different view today. Behind me is the LBCC ultrasonic immersion tank. Yesterday we coupled a transducer to a 70-degree wedge, and we coupled it in the interest of eliminating the air. If gas or air is trapped between the transducer face and the wedge material, virtually all the sound will be reflected. And so eliminating the air is very important to make sure we get the maximum amount of sound into the part as possible. So the wedge itself provides a 70-degree refracted shear wave. So we can calculate what this angle is, or what incident angle this provides that results in the 70-degree refracted shear wave. So I have a board that I'm going to roll in behind me, and we'll take a look at Snell's law and how that calculation is done, and we'll figure out what incident angle this particular wedge provides. So bear with me one moment. Okay, so you can see right behind me is Snell's law, and in its original form, it's sine of angle 1 over the sine of angle 2 is equal to V1 divided by V2. My preference and the way I've used it over the years is to reconfigure it to solve for angle 1 or angle 2. In this case, we know angle 2, we know the wedge provides 70-degree refracted shear wave. And so what's the incident angle? So if I configure the formula like this, I can solve for incident angle. I have so sine of angle 1 is equal to the sine of angle 2 times velocity 1, which is the lucite material. And so that's the first medium, right? The first medium that the sound is in is the lucite. So, and then we just divide that by the second velocity, which will be the shear wave velocity of steel. So I just picked a random steel, 302 steel, and the shear wave velocity is 0.123 inches per microsecond. So I'll flip the board around and we'll take a look at that problem and how that problem is solved. Okay, so you can see at the top of the board, we have an AWS wedge 70-degree refracted shear wave in steel. What incident angle does the wedge provide? So we're going to solve for angle 1. That's what we don't know. We take the sine of 70 degrees times velocity 1, which is the longitudinal velocity of sound in lucite. So divide that by the shear wave velocity of steel, and I work that problem out, and I get an answer of 0.809. So it's important to remember to take the inverse sine of that value to change it back to degrees. And when I do that, I get 54 degrees. So I have an incident angle of 54 degrees, and if I have a lucite steel combination, because the velocity of the steel is higher than that of lucite, I see an increase in the angle, and we call that refraction, of course. And you know that, having gone through the level 1 course already. It's just a little bit of refresher. So why do we want to introduce sound at an angle? And in the case of welding is arguably the most common method of joining materials in industry. So there's a lot of weld inspection being done. I am not an expert in weld inspection. My history is all with immersion UT and liquid penetrant. However, we want to be able to introduce sound at an angle because that puts our sound energy perpendicular to the direction of expected discontinuities. So for example, with rolled plate, we know with a rolling operation, we would expect discontinuities to be flattened and elongated and be parallel to the surface. So if we introduce sound at 90 degrees to the surface, our sound will be perpendicular to the direction of those discontinuities, and therefore will interrupt the sound and be reflected back to us. With the wedges, there are, of course, wedges of many different degrees. 45, 60, and 70 are very common. There are some wedges that provide adjustable angles, so you can change the incident angle. But the idea is the sound will skip in and then, let me redo that, skip to the bottom of the part and back up into the weld zone. So we'll have some better drawings of that than I could illustrate with my finger. But by getting sound to the weld zone, the fusion zone, the heat affected zone, that's where we expect the majority of weld discontinuities to be. So it's just the same idea as rolled plate. It's just we got to get the sound in at an angle so that it will be perpendicular to those expected defects and therefore provide reflection to us. So that's why we're using the wedges, and I just wanted to talk a little bit about that today. And I appreciate you tuning in, and we'll move forward with some videos moving towards calibration of the instrument. We'll be using the OmniScans, the OmniScan SX, and we also have some Olympus FX650s. So we'll look at calibration with those particular instruments, and the IIW block and the NavShoot block. Thanks very much for tuning in. Have a good day.